climate projections for the South Central US. And I am originally from Arkansas, but I have resided in Oklahoma since 2009. So I'd be curious to hear from you all in the chat where you all grew up from, because I'm sure that many of us today we're not where we necessarily grew up in our home state. And unfortunately, I can't see the chat. So if one of my co-hosts could read out what's being shared.
Brad says that he lived in Northwest Arkansas for 3 years, but he's originally from Seattle.
Very nice. Yeah.
And Monica is from Michigan, and she says, go green.
Very good, very good.
Katie says she grew up outside of Chicago, but moved to Idaho for a decade, then Nevada for 4 years, then Texas, and now Oklahoma. So she's been everywhere. Katie, wow.
Very nice.
And of course, Renee is from Madison, Wisconsin. Go, Pat, go. And that is her words and mine.
Great. Yeah, it's fun to see where all of us have come from and then where we end up today. So hello, fellow Arkansans that may be out there. So a little bit about myself again. I have a bachelor's degree in meteorology from OU, a master's degree in geography also from OU. It was one of those, I came here for the weather and then found my significant other and got married, and we've stayed. And now I work at OU. So I guess OU just wanted to keep me around a little bit. I am the University Assistant Director for the South Central Climate Adaptation Science Center, and I love what I do. Some of my hobbies are wildlife photography and baking, and I've put a little bit of my wildlife photography throughout this presentation, so hopefully it'll give you a nice little something to look at as we are talking about warming temperatures across the South Central US. So why even use future climate information in our decision making? I'd be curious to hear from you all in the chat why you think that's important for us to do or not do. Hopefully you're all still with me. Let's see, I think I'm seeing when it says, well, if we don't know where we're going, we can reroute. Yes. How can we adapt / plan ahead resource-wise unless we have an idea of what we think will happen? Absolutely, Brad. Which is kind of what I was trying to go with this picture. So if we're just using the information that is behind us, it's like driving looking in the rearview mirror. Which may be all well and good if your road is straight, but what happens when that curve comes up and you're looking in that rearview mirror, looking only at what's behind you and the data that's behind you? So we're not being prepared for what's coming if we're not looking ahead at that future data. So what does the future look like and how do we know? Climate scientists have used numerous global climate models to try to understand and model how our atmosphere works and project that onto the future so that we can have an idea of what it might be like. We'll talk a little bit about scenarios in a moment, but just kind of the basics of the global climate model is that they're trying to take all of the math and physics that many of us learned about in our undergrad and graduate degrees, take all of those, put it into a model. So these things are very, very complex, often running on like supercomputers, takes probably hours to weeks in some cases to run these models. They're very complex. trying to include not only what's happening in the atmosphere, but what's happening on the land and how the land's interacting with the atmosphere, how the ocean is interacting with the land and the atmosphere, how plants are interacting with all these different components as well. And then we talk about the human influences, which is where some of those scenarios come from. This is showing a global climate model output. And what you can see here is the realisticness of it. And that's because of all of those equations and all that math that we know. This is why we feel very confident in what the models are projecting. If you compare this next to satellite imagery, GIF of satellite over time, they look almost identical. It's picking up the general patterns across the world. Now, they're not all exact in terms of timing, but the patterns are correct, and that's what we need to verify. So emissions is where that human part comes in. There's a lot of uncertainty about what humans will do and the actions humans will take. But we can figure out a couple of different options based on emission scenarios, as well as other factors. So the global climate models that we often see shown in like the IPCC or the National Climate Assessment are using what's called representative concentration pathways. These are not exactly emissions. It's talking about like the amount of greenhouse gases that would cause a certain amount of change in radiative forcing in our atmosphere. But we talk about them like their scenarios because that's the best way that we can communicate what they are representing. So there's the high scenario, which is RCP 8.5, also known as kind of the business as usual scenario. Things keep going, chugging along as they have. And then all the way down to the lowest end scenario where essentially greenhouse gases just stop being emitted like immediately would kind of put you there. And then there's various scenarios in between. The global climate models, we can look at a regional level too. So these are some regional graphics. You see these broad, kind of broad swaths of different colors, tells you how things might change in general for your region. So this is for temperature, looking at that lower scenario. This is actually the middle scenario at 4.5, and then that higher scenario at 8.6, or 8.5, excuse me. And we see pretty much across the US a trend towards the warming. We can also look at, again, generally, regionally speaking, what precipitation might look like. And precipitation is very dependent upon the season that you're in, what type of change you might see. There will be seasons where it could be drier, seasons where it could be wetter. And we also notice that not everywhere is getting drier. There are some places projected to get a little wetter. But these graphics are, again, very kind of broad. It's hard to see that fine level detail, which is what downscaling is for. So downscaling is a method used to increase the resolution of global climate models from very kind of a pixel that covers the entire state of Oklahoma to now multiple pixels in Oklahoma that allows you to see those more local impacts and local changes. So a couple of my friends up in the corner there from the wildlife photography I was telling you about. So for regional climate projections, these are projections that we've actually developed in-house. Dr. Adrienne Wooten is kind of has been our main lead on this, and I will point to her to help me answer some questions if there are questions at the end. But we're just going to kind of go over these, and I'm hoping that I don't scare you too much with what I'm about to show you. So these are all, I'm going to show you all mid-century projections. We also have them available for the end of century. The mid-century is talking about the 2036 to 2065 range. So actually not that far in the future if you think about it. On the left-hand side, it's going to be the lowest scenario, that RCP 2.6 that I mentioned earlier. And on the right-hand side, it's that high scenario, so business as usual. Across Oklahoma, for this kind of annual average high temperature, we expect that to increase by about 2.5 to 5.5 degrees, depending upon what scenario you end up on. I don't know about you all, but I actually really hate the heat, so this does not make me happy. And I'd love to hear in the chat kind of what you think, what some of the impacts might be if you see this type of warming across the state in general. And my chat is disappeared again, so. Hot days, yuck. There's chat. Sob, yes. Jacob, oh yes, yeah, trying to walk outside in the summer heat. Yeah, no. Yeah, Adrian, absolutely. The mean, kind of these mean temperatures, it's hard to know exactly what those impacts are, which is why we've also kind of developed some different projections based on thresholds that I'll show you in just a moment as well. Really great. Thank you, everyone, for participating in the chat. So I also want to show you kind of breaking that annual average high temperature down into seasons, so we can see the seasonality across the South Central region. And again, these projections are just for the South Central region, but there are downscaled projections available for all across the US from various different sources. And as Renee mentioned in her presentation, we would love to talk with you about what's most appropriate for your use in your region moving forward if you have climate questions. So for the seasonality in our region, we're looking at, unfortunately for Jacob, who likes to take his walks, increase more in the summertime. Those summers are going to get a little bit warmer. We can also look at the projected change in the annual average low temperature. And this would be that kind of low, nighttime low, for example. And so we expect that those kind of low temperatures are also expected to increase, which can be pretty bad for like human health. At nighttime, our bodies need rest from those hot temperatures. And so if it's not getting cool enough, it actually can really hurt our bodies. So this is one of those thresholds that I was talking about, looking at the average number of days a year that it gets above 95 degrees Fahrenheit as that hot. And we expect, or our projections show, an increase of about 20 to 45 days on average, more than what we've had historically. So that's about another month to month and a half of these very hot days in a given year. We can also look at if that threshold becomes 100 degrees. So what's the annual average number of days that those the very hot days happen? And according to our projections, we see an increase of about 10 to 40 days. And that's just across Oklahoma. If you look a little bit further down into Texas, you see along the Texas-Mexico border, you see like 50 to 60 days more. So there are places that it could get really toasty for a lot longer periods of time. I see these and I kind of want to move northward. We can also look at the projected change of the annual average growing season length. So this one is based on temperature only, recognizing that growing season length has other factors that are important for it as well. But looking at just temperature, we do see that the growing season length is projected to increase by 10 to 30 days, depending upon what scenario you end up on, which could be good in some regions. So I do want to say that with climate change, it's not necessarily all bad, and through adaptation, we can make the best out of these situations that we possibly can. And as I kind of made a note earlier with that welcome poll question about the Dust Bowl and the importance of adaptation to help kind of offset some of these impacts, or at least lessen the impacts that we have to deal with. I'm going to switch over to projected change in the annual average total rain or snowfall. So for our region, we see, at least for that low scenario, not too much of a change expected for our region, which is good. But on that high end scenario, we do see a pretty good area of drying. Precipitation is interesting because it's much more variable in the models. It's a little bit less certain than some temperature projections, but we do feel relatively confident in these. And we are working on, and Adrienne could talk a little bit about this at the end if she wants, working on developing new graphics for those that are interested that would have areas shown where more models are agreeing on the magnitude or the sign of increasing or decreasing precipitation, just to kind of help guide some of those decisions with a little bit more certainty. Seasonal average, again, we see highly dependent upon the season that you're in, but for our region and in Oklahoma specifically, a decrease more during the summer and fall seasons, where it's kind of already dry, unfortunately. So before I move on, I kind of want to have you guys use the chat again. So we talked a little bit about temperature impacts. What does changes in precipitation mean for you all? What could that have impacts on? Major impacts to aquatic resources, yes. Less aquifer recharge, absolutely. Decreased base flow. Fire season severity, yeah. Precipitation and temperature would certainly impact that one. More or less storm chasing. Technically. Longer residence time in lakes. Streams drying up, yeah. Yeah, these are all really great potential impacts, just how precipitation might change and then what that looks like on the ground. So thank you all for sharing those. Let's see, this one is talking a little bit about droughts. So longest dry spell length, so the number of days where you haven't gotten any precipitation. And across Oklahoma, especially in western Oklahoma, we expect to see that to increase by about 1 to 2 days. So that longest period of time where it didn't rain anything, you didn't even get a trace, add another day or two to that. So those are just a very like kind of short list of the projections that we have available. We're continuing to grow that based on feedback from you all. So if there are thresholds that you're particularly interested in from temperature or precipitation, we'd certainly love to hear that from you all, what matters to you, so that we can figure out on our end, can we make that, is it feasible, and then how to work with you all on those decisions. The fine print of projections. Projections are not forecasts or predictions, even though sometimes I hear that language. They are not designed to tell you on August 24th of 2034 exactly what's going to happen. That would be really, I would not bet money on that model if it were trying to do that. But it just tells us in general what those trends might be like in the coming years, decades, and over the next century. Yes, and as I mentioned, interest in other maps or graphics should be sent to our info email. It just kind of helps us make sure that we're capturing everybody's needs and desires for climate projections. We'd be certainly happy to schedule a virtual visit with you to discuss any specific needs you have. And as I mentioned towards the beginning, we do have end of century graphics too. Those range from 2070 to 2099. And all of our ensemble projections are developed using 3 different downscaling techniques, using 3 different historical observation data sets and 3 different global climate models. So we try to make sure that we're really capturing and creating a data set that is robust and representative for our region. A few options for you all to just find out more about kind of what we're up to, and as our projections become live, we're going to start sharing those on social media in the coming weeks. So certainly follow us on Facebook or Twitter, sign up for our newsletter, which you can access on our website. And then a few links to our partners as well as our website that could be useful resources for you all. And brief acknowledgement of the funding source to develop these projections. And this is where I'll end us, and that's actually one of my favorite pictures of the squirrel I've ever taken. It was on a very hot summer day, and that is how I feel on hot summer days too.